Okay, we want to do a grid and a graph for the exponential function. And we start making the grid by drawing a rectangle and doing a vertical line through the center, and then a vertical line halfway from the center to the right edge, and a vertical line halfway from the left edge of the center. So we're doing type 1 graph, type 1 grid, let's say. And then we're going to subdivide from top toward bottom, halfway from the top to the bottom edge. Our first line, got it a little bit low there, but live with it. And then halfway from there to the bottom edge is our second line. Halfway from there to the bottom edge is our third line. Halfway from there to our bottom edge is the fourth line. Those aren't done exactly right, but they're fairly close. I think this one's a little higher than it should have been. But we can still live with this graph. And if you're no more precise than I was here, you're doing okay. If you're a lot less precise, work on it. So for the exponential function, our rule is start at the left edge at the lowest construction line. Move one to the right, one up, one to the right, one up, one to the right, one up, one to the right, one up. There's your curve. Now, if this function is in a 4x4 rectangle, which of course is a square, but it doesn't have to look like a square. It could be any rectangle labeled so that the height is 4 units and the width is 4 units. Okay, this tells us that there are 4 units here, 4 units here. The grid does include a red dot at the center of the lower edge. That's a type 1 grid. And red dot's going to be at the origin, which of course is the point 0, 0, which means that x equals 0 and y equals 0. That tells us that this line is the line x equals 0, because it goes through the point whose x coordinate is 0. It's a vertical line through the point where the x coordinate is 0. So the line down the center of the graph, the vertical line through the center of the graph, has to go through the center of the lower edge. And if that corresponds to the origin, then that vertical line has equation x equals 0. And the equation y equals 0 extends the boundary line. So here is where y equals 0. Excuse me. Okay, now if the height of this thing is 4 and y equals 0 here, then y is going to be 4 units greater here. So if we extend the top edge, that's going to be the line y equals 4. And I'll label it over here rather than over here because I wrote this stuff and it'd be in the way. Okay. And maybe I ought to put the y equals 0 on this side so we see the scale here. It doesn't hurt to have it over here as well, but we'll keep them on this side. You know. Okay. Then how do we label the x boundary lines? Well, here's x equals 0. This is 4 units, so this is 2 units. So here's x equals 2. Here's x equals -2. And then we can quickly fill in x equals 1 here and x equals -1 here. So now we've labeled all the vertical construction lines and all the boundary lines. We still have the horizontal construction lines. Well, this one is halfway between the top and the bottom, halfway between 0 and 4. That means y equals 2. And then halfway between 0 and y equals 2 is y equals 1. Halfway between y equals 0 and y equals 1 is y equals 1/2. And then this last line that I'll have to label over here because I got too much stuff over here is y equals 1/4. Well, we can now make a table for the type 1 graph in a 4x4 rectangle when the red dot is at the origin. So table of the construction points X values are -2, -1, 0, 1, and 2. The Y values, well, when X is -2, the Y value, well, it goes through the line Y equals 1/4, so the Y value must be 1/4. When X is -1, we come up that line to the graph point and see it's on the horizontal line Y equals 1/2. The X equals 0 point is on the line Y equals 1. The X equals 1 point is on the line Y equals 2. The X equals 2 point is on the line Y equals 4. There's a table. We could estimate values, put a line anywhere. I could estimate the X value and estimate the Y value, and it would be pretty close to the value of this function, which is the toolkit exponential function. Now there's an equation. There's a lot of algebra in this course, and we're going to start to get into some of the algebra. So I'm going to write y equals 2 to the x. That's the equation for this. So now we could label this graph the toolkit exponential function. The basic toolkit exponential function is y equals 2 to the x. Here's how we construct its graph, 4x4 rectangle with the red dot at the origin. Then our y values, well, let's just start with x equals 2. Okay, we get y equals 2 to the second, which of course is 2 times 2, which is 4. When x equals 1, y equals 2. Well, okay, when x equals 2, our grid point was 4, and our formula gives us 4. X equals 1, we substitute 1 for x, and we get y equals 2 to the 1, which is just 2, and that agrees with what we got from the construction. So kind of magically, we do this fairly simple construction, not hard to learn. Takes a little practice, but we have this neat formula that goes with that construction. We want to explain that. We want to understand that as thoroughly as possible. Okay, well, if x equals 0, we have y equals 2 to the 0, which equals 1. 2 to the 0 is not 0. No number to the 0 is 0. Any number to the 0 is 1. And I think we explained that previously. I'll probably give you a quick synopsis of that explanation. Okay. Now here we have y equals 2 to the -1. What is that? Well, let's just make sense of this. If we write out 2 to the 4th, that's 16. 2 to the 3rd is 8. 2 to the 2nd is 4. Stop and think. What comes next? On this side of the equal sign, what comes next on this side of the equal sign? What's the pattern? Well, the exponents go 4, 3, 2, so that pattern ought to be pretty clear. Let's just write that. Let's just continue that pattern. 4, 3, 2, what comes next? 1, what comes next? 0. 4, 3, 2, 1, 0. What's after that? -1. So it's 4, 3, 2, 1, 0, -1, -2, -3. What's happening to these numbers? Well, each one is half with a 1 before it. Half of 16 is 8, half of 8 is 4. Half of 4 is 2, half of 2 is 1, half of 1 is 1/2, half of 1/2 is 1/4, half of 1/4 is 1/8. And I hope you understand fractions well enough to understand that. 2 to the negative 1 is 1/2. Well, that's 1 over 2 to the 1, isn't it? 2 to the negative 2 is 1/4. That's 1 over 2 squared. So 2 to the negative 2 is 1 over 2 squared. 2 to the negative 3 is 1 over 8, which is 1 over 2 cubed. Important rule for exponents. Okay, I think we've seen that before, but just in case, I threw it in here. So that what? We got a 2 to the negative 1 here. That's 1 over 2 to the 1, which is 1 over 2. If x is negative 2, we got y equals 2 to the negative 2, which is 1 over 2 squared, which is 1/4. Everything matches. This picture shows you a lot of things, including why 2 to the 0 has to be 1. That's the only point that really fits a smooth curve through these other 4 points. Another reason you might want to say that. In some sense, this is the smoothest possible curve in existence, anywhere, mathematically. Okay, well, there's your type 1 grid, your exponential function, your table, and some calculations to go with the table. You absolutely need to know your rules for exponents in order to proceed very far in this course. And now, again, my tone is a little kind of rushed here and a little focused more than it is if I'm talking to a class, because video didn't pick up audio in the class, and I'm having to redo this and choosing to redo it kind of quickly, but to include everything. Okay, so we have the y equals 2 to the x, which we evaluated just now. Take another quick look at it. There it is. We constructed the graph. We made the table. So we're going to use that table again, but we're not going to reconstruct the graph. First, I'm going to construct the graph of the squared function, or the quadratic function. Okay, so I'm going to do this without much comment. It's called the toolkit quadratic function, 4x4 grid. Red dot at the origin. And I'm going to just do this without a whole lot of explanation. The first line we usually draw is a vertical line through the center. And if the red dot is at the origin, that's where it goes. It's on the lower edge of the quadratic function. This is a type 2 graph for type 2 grid. Okay, so I'm going to complete the type 2 grid halfway between the center, right edge and the center, halfway from the left edge to the center, then halfway from each of those lines to the center. Then, very similar to what we did for the type 1 grid, halfway from the top to the center, halfway from there to the bottom, halfway from there to the bottom, halfway from there to the bottom, and even halfway from there to the bottom. And that last line is important, although it won't be one of the grid points, because the rule is we sketch the graph by starting at the upper left-hand corner, moving right 1 down 2, right 1 down 2, right 1 down 2. And if we didn't have that last line there, we wouldn't have a line to skip. And then if we do that, we end up at the red dot. And then we go right 1 up 2. Again, we have that line that we're not really using except to skip it, but that's the 5th horizontal line. And then right 1 up 2, right 1 up 2. We sketch our nice, smooth, beautiful parabola. And that's our toolkit quadratic shape. Once we put a scale on it, well, here x equals 0, as red dot is at the origin as it was previously, and y equals 0. It's a 4 by 4 grid, so this point is 4 units higher than this. That means the upper boundary is the line y equals 4. The width is 4. This is halfway from one edge to the other. So this distance is 2, which means that again, x equals 2 here, x equals -2 here, identical to what we have for the exponential function. Now we have the line x equals 1 here. So I'll label that here. X, that's -1. And x equals 1 here. And then we have x equals 1/2, -1/2, it's better with it. And that's this line. And this line here is x equals 1/2. Usually we want to label it directly above the line, but these two kind of bunch up a little bit. But we understand now what the x coordinates and y coordinates are for all our grid points, and we list them. I'm not going to belabor this a whole lot. We have the point -2, 4, -1, 1, and let's do finish labeling the grid lines. Okay, this lowest grid line here. Well, let's start here. This middle grid line is halfway between 0 and we know that. And halfway between 0 and 2 is y equals 1. Halfway between 0 and 1 is y equals 1/2. Halfway between there, 0 and 1/2 is y equals 1/4. And then we have this line over here that we're not really using. I'm going to leave myself room. We'll say that's the line y equals 1/8. Okay, so again, -2 gives us 4, -1 gives us y equals 1, 0 gives us y equals 0. X equals 1 gives us y equals 1. X equals 2 gives us y equals 4. Except they didn't label all the points. You forgot about this grid point and this grid point. And I really forgot about it, so I'm going to erase some of this. Okay, here are the x values of our grid points. I left this one and this one off. Okay, so when x is -1/2, well, that's this line, and it meets the line y equals 1/4. When x equals 0, well, y equals 0, that's the red dot. When x equals 1/2, we're back up to the line where y equals 1/4. When x equals 1, y equals 1. When x equals 2, y equals 4. Now there's a formula for this. We also call this a squaring function. So let's do like we did before and write the symbols for the function, the formula for the function. Y equals x squared. So if y is -2, y here would then be -2 quantity squared. Now you have to have the parentheses around that -2, because if you wrote -2 squared by your order of operations, you'd have to square the 2 before you applied the negative. You get -4. And your calculator, if it follows the order of operations, would give you this. So a lot of people think you should get -4 here, but that doesn't make any sense at all. You're squaring -2, meaning you're going to multiply -2 by -2. And you're going to get 4, not -4. Okay. Incidentally, if I put the parentheses around -2, that's what it means. It means square -2. So with parentheses, -2 squared equals 4. make sure you understand this. Some software like Excel doesn't follow the order of operations completely, and many calculators decide to encourage ambiguity in mathematics and would write -4 for this expression. Don't believe it. If your calculator does that, get yourself a different calculator app. Okay, so anyhow, here. You squaring -1, you're going to get 1, because it's -1 times -1. Here, y equals 1/2 squared, which is 1/2 -1/2 squared. Because -1/2 times -1/2. You multiply numerators and multiply denominators. -1 times -1 is 1. 2 times 2 is 4. That gives you 1/4 who agrees with the construction. When x is 0, that's 0 squared, which is 0 times 0, which is 0, and that agrees. Here, y equals 1/2 squared, which is 1/4. Take the time to write out the details. Y equals 1 squared, which is 1. Y equals 2 squared, which is 4. And these numbers here that we end up with exactly match the numbers that we get from the construction. Okay. Biggest mistakes I see here just involve people thinking that -2 squared is -4. Okay, maybe your calculator told you that, but you never believe your calculator. Not completely. When it comes to the basic rules, there are times when you just really can't believe it. Okay, so there's your basic toolkit squaring graph. Okay, I'm not going to label it, but that's it. Your basic toolkit. Yeah, I better label it. I like to use the word quadratic. Basic toolkit, quadratic, or squaring function. This is how you can construct it. This is how you can use a formula to get the numbers. Okay, now we're going to do another graph, 4x4 rectangle, exponential shape with the red dot is 2, 0. Now we did an exponential shape previously, so I'm just going to draw this without comment. Here's our curve. Now, the toolkit function is y equals 2 to the x. This is not y equals 2 to the x because the red dot is at the point 2, 0, which means since this is 4 units wide and it's 2 units from here to here, this is now x equals 4, and this is x equals 0 over here. Now, this line is still y equals 0, 4 units high, so this line is going to be y equals 4. And this line is, well, I'm just going to label y equals 2, y equals 1, y equals 1/2. And a little hard to label there. Not much room over there. Well, I'll squeeze it in here. Y equals 1/4. x equals 0, x equals 4, halfway between 0 and 2, that's what this line is, that's at x equals 1. Here, x equals 2, and here, x equals 3. So there are our points. And now I'm kind of out of board space. Kind of got greedy with the board space, so I'm going to have to adjust a little bit. Okay. So I think we can still see most of this graph, and you know what the y coordinates are going to be. We can read off the coordinates of the graph point. This one is 0. This is on the line y equals 1/4, so we have 0, 1/4. When x is 1, we're on this line, which is y equals 1/2 line. When x is 0, we're on the y equals 1 line. Sorry, when x equals 2, we're on the y equals 1 line. When x equals 3, we're on the y equals 2 line. When x equals 4, we're on the y equals 4 line. So there is a table for the graph that we just constructed. Now the question is, what's the formula? Now let's see. Let's figure this out. Toolkit formula is y equals 2 to the x, but that's not going to work here. 2 to the x, if we put in 0, we're going to get 0, we're not 1/4. And if we put in 1, we're going to get 2 to 1, 2 instead of 1/2. Number's not going to be right. So what are we going to do? Well, what would we put in instead of 0? What would the exponent of 2 be if instead of, if we want to get 1/4? Okay, if we want to get y equals 1/4, what power of 2 is this? Well, that's the negative second power of 2. And this is the negative first power. And this is the 0th power, the first power, and the second power. How are we going to adjust the formula? We adjust the formula for our present graph by saying y equals 2 to the x minus 2. We'll see if that works. Okay, so let's see, let's evaluate it. If x equals 0, we get y equals 2 to the 0 minus 2, which is 2 to the minus 2, which is 1/2 squared, which is 1/4. Okay, that worked. If x equals 1, we get y equals 2 to the 1 minus 2, which is 2 to the negative 1, which is 1/2, which is what we want to get. We get y equals then 2 to the 2 minus 2. That gives us 2 to the 0, which is 1, which is what our graph shows us. Here we get y equals 2 to the 3 minus 2, 2 to the 1, that's 2, and that works. And then y equals 2 to the 4 minus 2, which is 2 to the second, which is 4. That works. So if we replace x by x minus 2, we get a graph that actually is 2 units to the right of our original graph. Now let me just draw a couple of small graphs here. Without going through all the details, we're going to let this be the exponential graph when x equals 0. We'll say, okay, y is 4, y equals 0, boundary lines are x equals 2, and x equals negative 2. If we want to do the graph that we just drew, well, it's in a square of the same size, but the line x equals 0 becomes our left edge. So how are we going to do that? Well, we just go ahead and draw us a little blue rectangle, 4 units wide. That just corresponds to this rectangle in this graph. And our graph looks like this. Okay, this graph looks just like this one. It doesn't, because I didn't do a good job of drawing it, but this graph is just this graph shifted 2 units to the right. So we shift two units to the right, and we get the blue graph. We shift each point of this graph 2 units to the right. Every one of these arrows ideally would have length 2. Every point of this graph corresponds to a point of this graph, but it's 2 units to the right. Now that's more than I said in class. It's worth looking at. I'm going to make a statement that we're going to generalize in another week or so when we get to it in open math. And that is that replacing x shift the graph to the right. And that's for any function, any graph. It replace all the x's in the function by x minus 2. Well, that means, like here, you get 1/4 instead of at x equals -2, as it was for the original toolkit function, first graph we made in this whole video. We got to go to x equals 0. Okay. X equals 0 is 2 units to the right of -2. To get 1/4, we've got to use a number that's 2 units more than for the toolkit function. In order to do that, we subtract 2 from the x value. That it's so you should really understand. Now, you have a 6-minute video posted for the. I'm getting an echo. Why am I getting an echo? This is a major problem. That wasn't an echo, that was my voice, which made me think it was an echo, but it was another video that was playing simultaneously. Okay. We're going to do type 3 grid and the reciprocal shape. And we can do similar with this. I was about to say that there is a 6-minute video posted under the 828 assignment on the assignments page, which you should be looking at, that goes through more detail on constructing a type 3 graph and the reciprocal function. I'm going to do it very rapidly just for completeness because I did it in class on Thursday. But we start by the same way we do with the square. Line down the middle, halfway from the right edge to the middle here, halfway from there to the middle here, and similarly the left edge. Now, what do we do horizontally? Well, we do the middle. Then we do halfway from the top edge to the middle and halfway from the bottom edge to the middle. Same thing we did with the vertical lines from the right edge to the middle and the left edge to the middle. Identical directions, except we're doing it with horizontal lines. Then what do we do? Well, before we went from this line to the middle, the line to the right to the middle, we're going to go from the line up to the middle, line above. Okay. Then from the line below the middle to the middle. So this graph is completely symmetric. If it's drawn accurately and you turn it 90 degrees, you can't tell it's been turned. Turn it another 90 degrees, you still can't tell. Any 90-degree rotation, this graph is going to look identical if it's drawn with perfection, okay? And that certainly isn't the case here. So what's our rule? Well, we've seen it before, but you start at the left edge. One right, one down, one right, one down. You draw a curve, okay? Start at the left edge, right below the middle. Then you start at the right edge, right above the middle. And you go one left and one up, one left and one up, and you sketch your curve. I commented, and I comment on the video, that if you continued the process on the left, you always go twice as close to the middle. So if we went twice as close to the middle, we'd be on a line here. And we'd go twice as far from the middle. Here, we're twice as far from the middle as we were here. Here, we're twice as far from the middle as we were here. So on the point that we would get here, we would be twice as far from the middle as we are here, which means we'd be way down here. Now, we still wouldn't be up to the center line. If we want to get closer to the center line, we go halfway to the center line and twice this far from the middle, which would be down below the board. And very rapidly, we get into very big negative numbers here, but we never get to the middle. And we never cross the middle, which is why we don't connect this point to this point. Okay, we can make similar statements about other aspects of the graph, but that's it. That's your type 3 grid. That's your reciprocal shape. Again, the 6-minute video tells you a little more slowly and slightly maybe different words, but it's going to tell you exactly the same thing. So if you understand this, you don't need that video, but if you're not sure here, look at that video.